In this video, we are going to be discussing applications of equation systems. Now, our first general set of applications is going to be general word problems. Okay. Now, a word problem, it can be kind of scary. A lot of people, when they were back in high school, they did not like word problems very much. Word problems are not as intimidating or as scary as you may originally have thought. A word problem is really just a math problem in disguise. It's just a math problem that has a story associated with it, okay? Now, the key is identifying pieces of important information in the word problem. So when we're dealing with word problems, you must identify important pieces of information and determine how these pieces are related to each other. Okay, that's really the key to figuring out word problems. Okay, so let's just jump right into a simple example of a word problem and do this. Again, we're going to identify important pieces of information and determine how these pieces are related. Okay, so let's look at this example here. Let's say that a bat and a ball cost $1.10. Okay, I don't know if a bat and a ball are really that cheap these days. Probably not. Let's just say it's a cheap bat and a cheap ball, but together they cost $1.10. The bat costs $1 more than the ball. How much does the bat and ball cost individually? All right, so that means how much does the bat cost by itself and how much does the ball cost by itself? Okay, now at first glance, you may look at this and think, oh, wow, this is so easy. This is 3 simple sentences, okay? The bat must cost $1 and then the ball costs 10 cents, but that's not correct. That would be wrong, okay? You have to set this up as a system of equations. So under solution, I'm going to say set up as a system of equations. Okay, so let's do it, all right? Let's define some variables. Okay, we're going to say define variables. And again, for word problems, again, they're a math problem, but they have a story with it. So you have to define what your variables are very explicitly, okay? So we're going to say be explicit and be explicit and exact. Be explicit and exact when you define your variables. So here's what I'm going to do. I'm going to say let x equal the cost of the bat. Okay, notice I'm being very literal here. I'm not saying let x be the bat, okay? You don't say let x be the bat. You say let x equal the cost of the bat, all right? And then we're going to say let y equal the cost of the ball. All right, and again, be very exact. You do not say let y be the ball. That's not really correct. You say let y equal the cost of the ball. All right. Now, we look back at our original three sentences and we ask ourselves, how are these sentences and this information related to one another, right? So the first sentence says a bat and a ball cost $1.10. So what do? Well, we can say the cost of these things together equals $1.10. So we're going to say x plus y equals $1.10, right? Isn't that what this first sentence is saying? The bat and the ball together cost $1.10. Well, we just said let x be the cost of the bat and let y be the cost of the ball. So that's where we get x plus y equals $1.10. Okay. Now, what did the second sentence say? The second sentence says the bat costs $1 more than the ball. Okay. So the bat cost is x, right? The cost of the bat is another word for equal. The cost of the bat is $1 more than the cost of the ball. So what do I write? Maybe pause the video and think about it for a second. So I would say x equals y plus 1. You could put 1.00 if you want. Okay? And again, where am I getting that from? Well, the second sentence here, the bat costs $1 more than the ball. So x is $1 more is a plus sign, than the cost of the ball. All right? So look at this. What do we have here? We have a system of two equations with two unknowns. And now all we have to do is solve for x and y, right? Solve for x and y. And when we solve for x and y, what will we have done? We will have answered this question. How much does the bat and the ball cost individually? Okay. Well, look at this. A system of two equations, two unknowns. You have a bunch of tools in your toolbox that you can use to solve this. This one is set up really nicely for substitution, right? I mean, x already equals y plus 1. So how about you substitute this y plus 1 into this term for x in the first equation? Okay. So how about we say y plus $1 plus y equals $1.10. Okay. So what happens when we make this operation here? Again, I've substituted y plus 1 into x from the first equation, and of course we get 2y plus 1 equals $1.10. Okay. And then, of course, we get y equals 10 cents, or just $0.1. I'm sorry, 2y equals $0.1. And then y equals $0.05, which is the same thing as 5 cents, right? So a nickel, okay? So there's y, and then what do? You substitute the value for y back into one of the previous equations. I would substitute it back into the original second equation, and so we can then get x equals $0.05 plus $1, so x equals $1.05, right? So finally, in summary, our summary is the bat costs $1.05 and the ball costs $0.05, which, $0.05 is 5 cents, of course. Okay. So that's our final answer now. And so does this still, obey the very first sentence. The very first sentence, remember, said a bat and a ball cost $1.10 together, and the bat costs $1 more than the ball. Yeah, absolutely. Look at this. Together, you add these together, you get $1.10. And then if you look at the difference between them, does the bat cost $1 more than the ball? Yeah. If you look at the difference is $1, which means the bat costs $1 more than the ball. It's not the same thing as saying one of them costs $1 and the other cost 10 cents. You know, if you had made that initial mistake, then you would be saying the bat cost 90 cents more than the ball, which is not what the problem asked for, okay? So you got to be very careful here, okay? Be very careful and be very direct, very exact when you're defining your variables. So that's going to conclude this first video, and we're going to do have some more examples after this in other videos.